Okay, so we're going to start out with the definition of a limit. And you've done this before in pre-calc, but here we go. We have our limit, and it says the limit as x approaches some number a. This does not mean negative a. That means approaches a from the negative direction. What that means is here's your x-axis, right? Here's your set of positive numbers, here's your set of negative numbers. So when we say that we approach some number a from the negative direction, that means we're coming right here from the left and we're working our way to the right. I'll explain a little bit more when we get a little further into it. And then that limit as x approaches some number a from the negative direction would have to equal the limit as x approaches a from the positive direction. So in other words, coming from the right. So this is the limit coming from the left, and this is the limit coming from the right. Okay, so let me just give you an example. So let's say I have the limit as of this function, okay? I'm going to just call it f of x. And let's say as x approaches, let's say negative 2 from the negative direction. So let's take a look at that. Well, here's negative 2 right here. But coming from the negative direction means coming from the left. So I'm looking for the graph to the left of negative 2, which would be this graph right here. And let's look at what happens. So as we approach negative 2, as this graph gets closer to an x value of negative 2, this is asking, what does the y value approach? It doesn't have to equal it, but this basically means as we get closer to negative 2, coming from the left-hand side, what y value are we approaching? Not reaching, but approaching. So I'm going to go back again and see as we get closer to negative 2, our y value gets lower and lower toward 0, correct? So then our answer would be 0. All right, let's try another one. So let's say I had the limit. I'm going to squeeze it in down here. The same function, okay? And let's go as x approaches negative 2. Let's go from the positive direction this time. And let's see what we get. All right, so we're going to go back to that picture again. Here is negative 2. Now we're looking for the graph that's coming from the positive direction. In other words, to the right of negative 2. Well, we've got this graph here, and we have this graph here. But we want the one closest to negative 2, which would be this one. Whoopsie. Which would be this one right here. So look at what's happening. As we're coming from the right, so as we are working our way from the right toward negative 2, what y value is this approaching? And do you see that this y value actually stays the same? And it is negative 1. So my final answer would be negative 1. Okay, now, according to this rule right here, a limit's going to exist if the limit coming from the left and the limit coming from the right are equal. Well, look, let's look down here. The limit coming from the left is 0. The limit coming from the right is not 0. These guys are not the same. So then what we would say then is, let me just show you, the limit of the function as x approaches negative 2 does not exist. All right, so I want you to just take note of something. Notice rather, I don't have a plus or a minus here anymore, because if the limit from the left and the limit from the right are not the same limit, then we say the limit as x approaches negative 2 doesn't exist. And when we don't see this little plus or this little minus here, you are to assume that you have to go back and look at the picture and look at the picture coming from the left and the right and make sure they're approaching the same thing. So in other words, here we go. Coming from the left, coming from the right, oh, they're not approaching the same thing. That means the limit won't exist. Okay, we're going to try some more. So let's turn the page. So go to page 3 in your notes packet and here. Okay, so here is number 1, which is on page 3. So let's look at part A here. So this is saying as x approaches negative 1 from the negative direction. Well, here's -1. From the negative direction means from the left. So we would be looking at this part of the graph here. And notice it approaches, it doesn't reach, but it doesn't matter. Definition of a limit just means what y value is it going toward, and do you see it's going toward a y value of 2. Okay, so then our answer here is 2. Let's look at part B. The limit as x approaches -1 from the positive direction. So in other words, from the right. So here's -1 again. To the right of that would be this graph right here, right? So let's follow it. From the right, we're working our way towards x equals -1. What y value am I approaching? And do you see that I'm approaching a y value of 2? So my answer here is 2. Now this is what I was just talking about on the previous page. Look at what we have here. The limit coming from the left and the limit coming from the right are the same. Let's go back and look at this picture. Look, limit coming from the left and the limit coming from the right are approaching the same y value. It's not it's not a closed circle, but it doesn't matter. Look, do you see that it's hitting that same point? So then, or coming to that same point. So that being the case then, part C, my final answer is 2. So when the limit coming from the left and the limit coming from the right are the same thing, then the entire limit, which is part C, would be whatever number we got here and here. Okay? All right, let's look at part D. That one's a little bit different. Now, look, this is what I'm talking about. There's no little plus or minus. So when that happens, they're asking you to look at the picture and look at x equals -4 and evaluate the limit coming from the left and the right. So let's go to -4. Here we go. Now look, coming from the left, we're approaching a y value of 3. Coming from the right, we're approaching a y value of 4. See that space there? That's a jump. So that means that this limit does not exist. Whoops, just dropped my stylus. This limit doesn't exist because the limit coming from the left and the limit coming from the right are not the same number. Okay, let's go and let's look over here, and we're going to do part E at x equals +4. So here's +4. Limit from the, now, hold on, let me back up. There's no plus or minus here, which means you have to look from the left and the right. So from the left, it's going toward a -3, and coming from the right, it's going toward a -2. Notice again, you have a jump here. You've got a break there, okay? So that means that we've got D, N, E. Okay, turn the page. Let's go to page 4. All right, so here is number 2. We're going to do the same thing. So part A and part B, if you look at them, they're telling you to come from the left and come from the right, and we're going toward x equals, an x value of 1. So here we go. Oh, look at that. So coming from the left, it goes to 3. Coming from the right, it goes to 3. See that there's no break or no jump in here? Okay, so then we can say the answer to A is 3, the answer to B is 3, and then look at choice C. It's telling you that if your answer to A and B are equal, then the limit as x approaches 1 would be that number, which is 3. Okay, let's go to part D. So we have x approaches -5. Now, there's no little plus or minus there at the end, so that means, remember, we have to look from the left and the right. Well, look at what happens here at -5. You have a jump here. Coming from the left, it's going to +2, but coming from the right, it's going to +3. So then that means that entire limit does not exist. And if you look at +5, in part E here, +5, again, there's no plus or minus, so we have to look coming from the left and coming from the right. But look, you can see that jump right there, just like at -5, right? So we know that that answer is also DNE. All right, let's turn the page. And we are number 3 on page 5. Okay, we're going to do the same thing again. This one says -2 from the negative direction, -2 from the positive direction, and look, just a plain old -2. So if these guys are the same, then whatever number they are, that's the answer here. These guys are not the same. It's D and E. All right, so let's look at negative 2. Well, here's negative 2. Coming from the left, it goes to negative 2. And coming from the right, it goes to negative 2. So we know that we've got negative 2 here, negative 2 here, and negative 2 there. All right, let's look at part D. This does not have a plus or minus after it, which means you have to look at x equals negative 4, coming from the left and the right. So here's x equals negative 4. Coming from the left, we are approaching 2. And coming from the right, we are approaching 3. You've got to jump here. So remember, that's a no-go. So that limit does not exist. All right, and let's look at part E. Part E is the limit as x approaches 3, right? No little plus or minus after that number. So that means you have to look coming from the left and coming from the right. Notice there's no jump here, so we're good to go. That is negative 2. All right, last one. All right, so we're looking at number 4 on page 6, and it appears as if my picture got a little cut off here. Sorry about that, but you can see that in your notes packet. That's x approaches 2 from the negative direction, and this is 2 from the positive direction, and this is obviously approaching 2. So let's look. Coming from the left, we're going to a y value of 2. Coming from the right, we're also going to a y value of 2. So then that obviously means that this answer is 2, this answer is 2, and so is that one. Okay, and let's look at part D. So then part D is saying the limit as x approaches negative 4. Again, there's no little plus or minus, so we have to look at both sides of negative 4. So here's negative 4. Well, coming from the left, we're going to 0. Coming from the right, we're going to 0. So then we know that that answer is 0. And then the last one, part E, is x approaches 5. Again, no little plus or minus. So we have to look at both ends of 5. In other words, coming from the left and coming from the right. And do you see they meet at this y value of negative 1? So that answer is negative 1. All right, there you go. So now your homework is going to be, let me just look here. We just did pages 2 through 6. So again, you can look on Google Classroom. You'll see it there, but you're going to be doing pages 8 and 9. Okay, pages 8 and 9. Have a great day.